Good afternoon, everyone. Mr. McRae here again, doing another video, this time on solutions of linear equations. Okay, this is our last concept that we're going to be talking about in terms of graphing. So again, we will have a test sometime. I think not end of this week, but next week on all the stuff that we learned in linear equations. Okay, so let's talk about what is solutions. The word solutions mean. Okay, I think everybody should know that. What is a solution? A solution is an answer to a question. Okay. Now, what about solution in terms of math, though? Okay, so it's a little different. What is it in terms of math? Okay, now it obviously is an answer to a question, but what question are we asking? Basically, we're asking is it is what makes an equation true? Okay, so that's what a solution is in terms of math. What makes an equation true? All right. So let's think about it in terms of this. All right. Let me give you an equation. Y equals 3x plus 3. Okay. Now, what we're going to say is, let me see, 2. Okay. What about this? 2 and 9. This little coordinate point 2 and 9. Okay, what do we know about this? All right, so basically this coordinate point, this is the x, this is the y. So what I can do is I can substitute in the 2 here and the 9 here for y, and it should be a solution because it makes the equation true. All right, so let's do that. So 9 equals 3 times 2 plus 3. So we have 6 plus, then we have 6 plus 3, and that's equal 9, and this is 9 equals 9. Okay, so that proves that this is solution of the equation. Okay, so that's what we're doing in math at this point is we're trying to find out where the solutions are of these linear equations. So let's also look at it graphically so we can see what I'm saying to show you that this 2, 9 is a point, is a solution of this equation 3x plus 3. Okay, so let's actually graph this. All right, so remember how to do that. Remember the b is 3 and the m is 3 over 1, which is the change in y, change in x. Okay, we all know that. So let's go up 1, 2, 3. Here's 1 point. Oh, hold on a second, make another layer here. Okay. Okay, this would be 3 right here. Okay. Sorry about that, guys. All right, so it'd be 3 right here. And then what do we have to do? We have to go up 1, 2, 3 over 1. You do that again, up 1, 2, 3 over 1. So here's the line as it goes along in the process right now. 3x plus 3. Okay. So what do we know about the coordinate point though? 2, 9. So we're saying that's the solution of this equation. So let's go that 1, 2, and we go up 1, 2, 3, 4, 5, 6, 7, 8, 9. Boom, right here. That's a point. 2, 9. So as you can see, this coordinate point is a solution because it runs on the exact same line as the equation. Okay, so that's the idea. Okay, so the equation and then the coordinate point should go right on the same line as the equation itself. So that's when you know this is a solution. Okay, it checks off. All right, so that's what we're going to be doing now is we're going to be determining if we have in a solution. That's what we're going to look at in terms of an equation like this with the x and y. We're also going to look at it in terms of a graph as well. So we're going to start looking at two equations or two lines and trying if we can find a solution of that as well. Okay, so let's move on and let's try this. Okay, so let's look at the first equation. So we're not going to basically most of the time we're not going to build a graph on this, but this information will be mostly found algebraically. Okay, so we have x is negative 4. I mean negative 5, and we have y is 4. Okay, so what I'm going to do is I'm going to plug in for the value of x 5. I'm going to plug in the value of 4 in for y, and I'm going to see if this equals 18. If it is, then it's the solution. If it doesn't, then it's not. Okay, so let's do it. So we have negative 5, okay, plus 3 times 4 equals 18. Okay, so if I do my PEMDAS here, negative times a negative is a positive. Okay, this becomes 12, and this becomes 18. Okay, stays 18. So we have 17 equals 18, not equal to each other. So there is no, this is not a solution. Okay, that's it. Oh, I didn't mean to put a question mark. I mean to put exclamation point. Okay, so that would be not a solution. All right, and that's all you have to do. Basically, just plugging in the values into the equation, solving them, and seeing if they're actually equal to the value on the right hand side. If they are, then it is a solution. If it's not, it's not. Okay, and basically what I'm saying is that it's the solution means it's not on the actual line. So that coordinate point is not on the line. All right. So let me do another one so we can see it again. So we have 4x minus 2y equals negative 32. So again, we're just going to plug in a value. This is x, this is y. So let's plug them in. So we have 4 times 5 equals 2, negative 24 equals negative 32. Okay, so let's do this. This is 20. This is plus 48. Okay, because we got negative 2 times 40 times 24 gives us 48, and that's positive. So we have positive 20, positive 28, and that's equals negative 32. Okay, so that would equal 68, and this equals negative 32. So that's x. That is no solution. Okay. And that would be it. So there will be times when there are solutions, guys, obviously. But I mean, I just wanted to show you how easy this basically is. It's just plugging in the values into the equation and then basically solving it. So it's very similar to what you did when you find the x and y intercepts. You plugged a 0 in for x to find the y. You plugged in a 0 in for y and solve for x. So I think you guys should be able to do this pretty easily. Okay, so that was the first portion of it. So let's go on to the other portion of basically looking at the equations. Okay, so let me just actually put a layer on this. Sorry, guys. I keep forgetting to do that. All right. So, now we're going to start looking at solutions of two equations. Okay. Okay. So we have this equation here, y equals 1 half x minus 1. So we need to know the b and the m for that. And then we have this one, negative 3 fourths x plus 4. So we need to know the b and the m for that. Okay. So, what is the b for the first one? How do we do this? Negative 1. Okay, we know and the m is 1 over 2, which is change y, change x. B in this one is 4. M is, remember, it's a negative 3 over 4, because remember, it's a negative in front. It's always going to go with the top number, not the bottom. Negative 3, 4. And I'm going to put change y, change x. All right, so then all we just have to do at that point is graph it and see where they cross to tell me what the solution of the two equations are. Now, when we get in ninth grade, you'll learn more about, there's other ways to do this other than just doing this. You can use it, there's elimination, there's algebraic ways to solve this as well, but we're mostly most focused on you guys getting the graphing down. Okay, so let's do it. So we have negative 1 here, that's 1 point, and then we have 1 half. Okay, so we go up 1, 2, and over what? Nope, 1 half, sorry. Up 1 over 2. Boom. There's a point right there. We can do it again. Up 1 over 2 again. There's another point. Okay. There's one line. Now, let's do the next one. So we up 4. 1, 2, 3, 4. Boom, right here. And then we go down 3. 1, 2, 3 over 4. 1, 2, 3, 4. Boom, right at that spot. Boom, right there. Okay, so at this point right here where the lines cross, this is the solution. So the solution to this would be 1, it'd be positive 1 and positive 4. So it would be 4, 1 would be the solution. Okay, so the solution of this would be coordinate point 4, 1. And that's what you'd have to do in this question. That's it. That's it. Just find out, just graph the points, find out where they cross, and basically take down those coordinate points, and that would technically be a solution. If you wanted to check that, you can just plug in your 4 and your 1 into these equations. Now, if you plug them in, they both should end up with the same answer on both sides. Okay, so if you plugged in 4 for x, 4 for x here, and 1 for y, you both should have the same answer. So you definitely know they're solutions as well. Okay, so let me try another, show you another one, and then we'll be done with this and let you guys go and practice. Okay, so look at this again. Now we have, oh, it's a different one. There's a strange one here. Okay, so we have to find the b. Oh, hold on a second. Sorry. All right, so we have to find the b. Ah, sorry, guys. The layer thing is not working for me right now. There it is. Okay, so whoa. Sorry, guys. Ugh. Ugh, sorry, guys. It's terrible. All right. So again, like I said, just sorry about losing that. Anyways, so I need the B and I need the M. Okay. So the B in this situation would be 4. Okay, and the M would be, remember, the negatives here, so it goes with the top number of the numerator. So it's -1/2. Okay, just like that. Now remember this, and this one is just x equals 4. So this one has no y-intercept. So this one just a straight horizontal line. Actually, vertical. Sorry, vertical line. Okay, so let's do this one out. So again, we go up 4 to this point right here because that's what the y-intercept is. We're going to change y, change x. Okay, so we go down 1 over 1, 2 to this point right here. We can do another one if we want. 1, 2. Make a low point if we want. Okay, and the reason why I did that, make 3 to help me make this as clear and accurate as possible. Okay, so that's 1. Now the another one is x equals 4. So we go down to x is 4. All right, right here. That's the point. Okay, there's no y, so that's like the x-intercept. And then all we do is make a line going all the way up like this. Okay. And they said, what is the solution here? So in this situation, the solution is 4, 2. Okay, that's the solution. Okay. So again, that's all you would have to do in this situation. Basically, is graph both points, find out where they cross, and take down the coordinate points. Okay, and that's it. All right. And the other one is basically substituting in values into the equation to see if the equation is true, and that it would technically be a solution. So these are the two things we're going to be doing today on solutions. Bye now.